Okay, so this is the apology to Casey Gilbertson. Casey, we're sorry. I'm sorry, Casey. And I don't know about the rest of your friends, but Casey, you're gone today, and we miss you. So there we go. Okay, so I really hate having you take your own notes because I see people go through them and they're flustered. They're like, well, I don't know where to find the right stuff. I don't know where to find what I've written down. I apologize. I really do. Um, I graded your test last night, so it's like, why didn't I make a note sheet for calculus? I graded their projects. Why didn't I make a note sheet the previous day? I graded other tests. Trust me, I do not do anything other than go home and work. That's all I do. My wife hates me right now. She does. She wants nothing to do with me. She says all you do is work. We never see you. That's where I'm at. So trust me, I'm not going home and watching Law and Order for 3 hours. That's not what I'm doing. Which I would like to do. I love Law and Order. Anyway, converting rectangular to polar and polar to rectangular. So you have some coordinates. We want to know how to take x, y, and move it back and forth between r theta. How do we do that? Well, there's some relationships that exist that we have to outline here. And first of all, I'm just going to plot a coordinate. I'm going to plot xy. See it? I'm going to draw a line to represent the polar coordinate. Whoop. Bad attempt at hitting that point. Try that. There we go. Okay. So there I have that coordinate xy. And we all know that you can also represent that coordinate as r theta. We all on the same page? That's what we did yesterday. I had you guys practice that. If you didn't practice that, you're behind. And so every day you get behind, you're going to be less and less likely to understand the material. So I've got the green, I've got the blue. Okay? That's going to form a triangle. I can use that triangle to represent certain portions of this graph. Namely, the green is going to be x, and the blue is going to be y. There are relationships that exist here. If I want to solve for x and y, r and theta, I can use trig to help do that. Watch this. Would you guys all agree that x squared plus y squared is equal to r squared? So if you want to find r, all you have to do is square x, square y, and then square your answer, right? That's all you have to do. That's seriously that simple. I also know a relationship for theta. Tangent of theta is equal to y divided by x. Does everybody see where I got those from? I mean, that's just basic right triangle trig. That's back from geometry freshman, sophomore year. Yeah? Covered it again this year. This is what you do to go from rectangular to polar. You can read your book. You'll see the same thing in there. Now, let's say we want to go from polar to rectangular. Well, that's a little bit different. I'm going to use theta, r, and x here to express the relationship. Namely that the cosine of theta is equal to what? What's cosine of theta? SOHCAHTOA. adjacent over hypotenuse, which is x over r. And sine of theta is equal to y over r. So if I want to figure out what x and y are, I can use this and solve for x by multiplying both sides by r. And I get r is equal to x cosine of theta. And I get, whoop, I'm sorry, did that backwards. R's, x equals r cosine of theta, and y equals r sine of theta. And that's what we do to move from polar to rectangular. So we got to be able to transition back and forth. Those are the formulas that we use. That's going to be your basis for your work today. Any questions? Let's make use of it. Example 3. Convert 3, negative 3 to polar form. I don't do this just because I want to provide you a visual or try to, have good teaching methods. I do this because I want to confirm my answer. So I encourage you to do the same. I draw a graph. Convert 3, negative 3 to polar form. Well, if I'm over 3, down 3, which quadrant am I in? In the fourth quadrant. This is 0, this is pi over 2, this is pi, 3 pi over 2, 2 pi. So your angle should be between 3 pi over 2 and 2 pi, correct? So we want to convert from rectangular into polar. How do I do that? I set this up. X squared plus y squared is equal to r squared. 3 squared plus negative 3 squared is equal to r squared. Or 9 plus 9 is equal to r squared. 18 is r squared, so what's r? 3 roots of 2, very good. 3 roots of 2 is my radius. So if we want to write it in polar form, we need r, and we need theta. Well, I found r. R is 3 roots of 2. Now I have to find theta. In order to find theta, I set up my second piece. Second piece is tangent of theta. It's equal to y. What is your y value? Negative 3. Divided by x. What's your x value? 3. So tangent of theta equals negative 1. Where is tangent of theta equal to negative 1? 135, that's the second quadrant. 315 is the third quadrant. That is also 7 pi over 4. So I have my r value, I have my theta value. I've converted now from rectangular form into polar form. I have 3 roots of 2, and I have 7 pi over 4. That is my final answer. Oh, I'm sorry. 135 is in the second quadrant. 315 is in the fourth. 7 pi over 4. Any questions? How I got that? X squared plus y squared is r squared. Tangent of theta equals y over x. Solve. Find the pieces. Make sure you're in the correct quadrant. Piece of cake. Can we do one more? You do it on your own. Go. Your answer is r is equal to 2. Theta equals 4 pi over 3. Any questions how I got that? Any questions? Going once. Twice. Yo. Theta. Tangent of theta is equal to y. Negative square root of 3 over x. Negative 1. So tangent of theta is equal to the square root of 3. So you find out where is tangent equal to square root of 3. Well, that's either 60 degrees or 240 degrees. Express that in radians. That would be either pi over 3 or 4 pi over 3. Since you are working in the third quadrant, because both your values are negative, it must be the 4 pi over 3. How's that? Good. Okay, next example. Example 4, convert 4 negative 3 pi over 5 to rectangular form. Okay, so if I go 4 negative 3 pi over 5, let's start with the angle. Where's negative 3 pi over 5 put me? Which quadrant? Okay, no. Close. You guys all agree that that's negative pi over 2? Or negative 2.5 pi over 5? So negative 3 pi over 5 would be slightly past that, correct? So, and it would be 4 units out, so, something like this. For this is a length of 4, and that right there is negative 3 pi over 5. So I'm in the third quadrant. Now what we want to do here is we want to convert from polar to rectangular. Well, I know how to do that. X equals r cosine of theta. Y equals r sine of theta. So all I have to do is grab my x values, my y values, and my theta values, plug them in, and see what I get. So I have x is equal to 4 times the cosine of negative 3 pi over 5, and I have 4 times the sine of negative 3 pi over 5, which I have no idea what those values are, so I'm going to have to go to my calculator and actually come up with some decimals. But Riz is quicker than I am to the calculator, so she's going to calculate the first one. That's my x value. And Andy's going to do the second one. No? Yes, he is. Somebody's going to give me the next one. So we've got negative 1.23 and negative 3.8. Now, look at my graph. Negative 1.23, negative 3.8. Does that look like it fits about the right spot? It sure does. If you'd like to check your answer, draw a graph, make sure it looks like it should. Furthermore, if you did x squared plus y squared, you should come up with 4. Well, 16, then square root, you get 4. So there's different ways to try to verify your answer, make sure that you're in the right mode. But drawing a graph ahead of time is, that's great. Any questions on that one? That's easier than the other one, right? That's easy. Okay. Well, what if instead of a coordinate, we have an equation? And this equation has a whole bunch of coordinates that we would like to turn into polar form. So we want to put that entire rectangular equation into polar form. That's what we want to try to do. Okay? So What does x equals 2y look like? If I divide both sides by 2, I get y equals 1/2 x, correct? And if I draw that graph, what does that graph look like? What does a graph of y equals 1/2 x look like? Bueller. Positive slope, 1/2. Something like that. Okay. So it's a line. It passes through the origin. It's got a slope of 1/2. It's got a y-intercept of 0. Now think about this, people. If we want to convert this to polar form, if we want to convert this to r theta, okay, does the angle ever change? No. The angle's the same. It's just either the radius is positive and always changes, goes on forever, or the radius is negative and goes the opposite direction. So theta is what's going to describe this. We don't care what the radius is. The radius could be absolutely any value. It could be 10, then we'd have a point out here. It could be -5, we'd have a point back here. We just need to know this angle. So instead of having an r value and a theta value, solving for this equation, all we need is really a theta value. Let's see if we can come up with it. I have x equals 2y. Instead of writing x, I'm going to write r cosine of theta because that's what x is. And instead of writing 2y, I'm going to write 2r sine of theta. Does everybody see where I came up with those two pieces? It's imperative that you see where I got that. What does each side have? An r. And if I divide off the r, they cancel. Well, what did I just say about this problem? Does the radius matter? No, the radius has an infinite number of different values if you look at the line. So I end up with a new equation. Cosine of theta equals 2 sine of theta. Well, what's generating this equation? The angle value, correct? So what do I have to solve for in this problem? I have to solve for the angle. Very good. And in order to solve for this angle, this is section 7.5, which you tested on a couple weeks ago, we need to be able to solve for theta. Any idea how you want to do that? Good. Say it. Good. Divide both sides by sine. You saw it. And if you do cosine divided by sine, you get cotangent of theta is equal to what? 2. Which means the tangent of theta is equal to 1/2. I have to solve for that. How do I solve for tangent theta equal to 1/2? I inverse tangent, and I'm going to work in radians because that's what we like. Mode, I'm in radians. Tangent inverse of 0.5, and I get 0.46. So that's my answer. The equation that will describe that line is simply theta equals 0.46. Done and done. That's your answer. Instead of the equation being x equals 2y, the equation is theta equals 0.46. X squared plus y squared equals 25. Got 2 more examples there quick. What does that graph look like? Circle. Or the radius of? Radius of 5. Is the radius always 5? Yeah. Does the theta value change? Sure it does. Look, right here you have a radius of 5, and you have a theta value. Over here, you have a radius of 5, and you have an entirely different theta value. So theta will just continually go around and around and around and around and around. So, does theta matter at all in this situation? No. It's going to be whatever it wants to be. The radius does matter. Let's insert r cosine theta, square it, plus r sine of theta squared equals 25. Here's a little trick. I'm going to square everything. So we get an r squared cosine squared of theta plus r squared sine squared of theta equals 25. Somebody saw it first hour. We'll see, or second hour. We'll see if you guys see it. You see what I can do? Cosine squared plus sine squared is 1. So we just need to factor out a r squared. So therefore, this middle part, exactly like you guys saw, is equal to 1. So you just have r squared equals 25. Well, if r squared is 25, what is r? 5. And so that is the equation for this graph in polar form. That's all you need to do. Yes, on the test, you have to verify that that's true. You can't simply just say, well, I know it's a circle, so r is 5. That doesn't work. So let me show you really quick on your calculator. If I go to mode and I go down to polar and I press enter and I go y equals and I type in 5 for my radius, press graph, look at what I get. A circle. Okay, last one. We got time. This is quick. X equals -2. What does the graph of x equals -2 look like? Yeah, a line going through -2, a vertical line, right? Can you graph a vertical line on your calculator? No, you can't. Why? It's not a function. It doesn't pass a vertical line test. Is that weird? A vertical line doesn't pass a vertical line test? Okay. Okay, so we got x to -2. We want to turn into r theta. So instead of x, what do I write? R cosine of theta equals -2. Now, watch what's happening here. Okay, watch this. I'm going to pick a point. I have an r value and I have a theta value. Do those change? Yeah, they sure do. Look at this one. I have a bigger r value, and now I have a bigger theta value. Okay? Would you agree that there's a connection between the r values and the theta values, that they depend on one another? As you decrease one, something happens with the other. So r and theta will both pop up in this type of equation. I need to solve for r in order to plug it in my calculator, so I'm going to divide both sides by cosine theta. If I divide by cosine theta, I get r is equal to, what's -2 over cosine of theta? What's 1 over cosine? Say it, Tara, with confidence! Secant! Is it possible that that equation could generate a vertical line? Let's check it out. Go into my r value. I type in -2, and I have to go divided by because I don't have a secant button. Theta. Theta is just your x value, your variable. And I go to graph. Watch this. Are you ready? Whoa! Look at that. Graph a vertical line. So you can check to see if you're right. You have a full work day tomorrow, guys. I'm gone all day. Sorry, I'm at a track meet. There you go. You've been a great audience. Tell you what, tomorrow, no ticket price. You get into class for free. You should be paying me for the grades you're getting, Bailey Barber. What? Oh, wow. Oh, yeah. There is a school district that in order to increase attendance policy, they pay their students to come to school. So, well, they just tax the community more. It's just like your parents paying you to come to school. Well, you know. I like the parents who fine their kids for not coming to school. How's that? Instead of being paid for good grades, Parents fining kids for bad grades. I've heard of that before. Oh yeah, very real.